Hello, let's continue our Sudoku adventure with Exurbia by rockratzero. So this finishes our skyscraper theme week, but do read the rules because these are not necessarily all skyscrapers. All right, in fact, we know for a fact that many of them aren't. All right, so let's go over the rules. We do have normal 6x6 Sudoku rules, so in each row, each column, and each 2x3 box, we are placing the digits 1 to 6 exactly once each. Now, numbers outside the grid are either skyscraper clues or exum clues. It is up to us to figure out which one it is per clue. So it's not like all of them are exum or all of them are skyscraper. On an individual basis, we have to discover which one's which. But if there are two clues for the same column or two clues for the same row, like this 1-3, like this 3-3, then it must be one of each. But we don't know which is which, but it must be one of each. Now, how do skyscrapers work? So let's say this 3 was a skyscraper. Yeah. That means that exactly 3 digits from this direction are larger than all of the digits before it. So we like to visualize this as skyscrapers, like the buildings. So if we were standing on this 3 and we were looking down this row, how many buildings can we see if the digit is the height of the building? So let's say this was a 3. That would be a 3-story building. Now it's right in our face, so of course we see it. Now behind the 3, there might be, say, a 1. Now we can't see the 1-story skyscraper because it is hidden by the 3. But then we might have, say, a 5. And we would see that because 5 is taller than both of these buildings. It's taller than this 3, taller than this 1. So we do see it behind that 3. And then this might be, say, a 4, and then a 6, and then a 2. So we don't see the 4 because it is smaller than the 5, smaller than one of these 3. We do see the 6, it's bigger than everything. And then we don't see the 2 because it's smaller than almost all of these. So we count how many skyscrapers we see, 1, 2, 3, and that is the clue. So if this was a skyscraper clue, that would be one way to fulfill it. All right. Alternatively, these could be exums. So they're pretty small. Let's use the biggest one, the 6. The way exums work is whatever digit is right next to the clue. Let's say this is a 2. That digit determines how many cells we use in order to sum to the clue. So in this case, if this is a 2, we use 2 cells, including itself, to sum to 6. So this would have to be a 4, because 2 plus 4 is 6. If this was a 3, on the other hand, we could do, say, 1, 2 here. We'd use all 3 of these. Because this is a 3, we'd use all 3 of these. And those do add to 6 as well. All right, and that's it. Those are the rules. There's a link in the description if you'd like to try the puzzle yourself. And I'm going to get started right now. I'm going to start with this 1. Because a 1 skyscraper must have a 6 next to it. Because the 6 is going to block everything else. Otherwise, you always see the skyscraper that's right next to the clue and the 6. So the only way for it to be a 1 is if it is a 6. Now, it doesn't have to be a skyscraper though. It could be an exum. And if it's an exum, the only way that we're adding to 1 is to use 1 cell, which is filled with a 1, and that adds to 1. So this is actually only 1 or 6. This, if it was a skyscraper, this is actually interesting. Yeah. So it doesn't work as a skyscraper. We notice it's opposite this 4. And so it's either a skyscraper or exum, making the other one the other one. Anyway, if this was a skyscraper, we have to go 1, 2, 3, 4, 5, 6. It's the only option to see all 6 of them. You have to just start with 1 and increase by 1 each time. And so what would that mean for this 4? Well, if this is a skyscraper, this is an exum. And this is saying use all 6 cells. And that's going to sum to 21. And that is definitely not 4. That's a little bit too big. So this cannot be the skyscraper. So this must be the skyscraper. So first of all, that means this is a 2 or a 3. If it's a 2, it puts a 4 here. And if it's a 3, it puts a 1 or a 2 here. I already went through those examples in my rules. But in case you didn't watch the rule description, you obviously can't put a 1 here because that would just add to 1. And so we have to add it to 2. We have to use 2 cells or 3 cells to add to 6. So this is 2 or 3. If we use 2 cells, it's definitely 2 plus 4. If we use 3 cells, it's 3 with a 1, 2 pair. I can't pencil this one because I don't. If this is a 2, it doesn't affect this cell at all. But I can pencil this one because it's affected by both. Okay, so that means that if I should start using some colors here. I'll use purple for Exum, and then I will use blue for skyscraper. Actually, those are a little close together. I'll use green for skyscraper. Okay. They are green skyscrapers. They're eco-friendly. All right. So how do we pencil skyscrapers? Well, one nice way to think about it is we need to see exactly four of the cells in this column. Well, there's 6 cells, meaning exactly 2 of them are hidden. So this could obviously be a 1. That doesn't hide anything. It could be a 2 because that only hides the 1. So that's only hiding 1 cell. It could be the 3 because it hides the 1 and the 2, which is also fine because we can hide 2 cells. But it cannot be 4 because if it was 4, it would hide the 1, 2, and 3. And that's already on its own hiding 3 cells, and we only can hide 2 cells. This is only 1, 2, 3. Now, as we move forward, we can be 1 higher than the max because this can be a 4 because we do see this one. So the 4 hiding the 1, 2, hiding the 1, 2, 3 wouldn't be a problem because this is already one of the 1, 2, 3. So it's in front of the 4. So it is seen. So it would only hide the other 2, which is fine. So, but you cannot actually, it's not a thermo. You don't go 2, 3, 4. It's a skyscraper. This can still be a 1, right? This could go like 3, 1, and that's perfectly fine. So we pencil 1, 2, 3, 4 here. And then here we can pencil 1, 2, 3, 4, 5. And that actually places 6 in the column right here. Only placed for 6. And actually this is only placed for 5. So we are seeing this 5, 6. And then we aren't seeing these 2. So these are the 2 skyscrapers that are hidden, meaning these 2 cannot be hidden. And so that does make this like a little 2-cell thermo, where this needs to be smaller than this, meaning this can't be a 1. It could be up until we proved that this was 5, 6 in this order. Okay. We know one of these 3s is an Exum, and 3 is quite restrictive. It has to be 2, 1. That's the only option. You can't use 3 cells to add to 3, and if you use 1 cell, it only adds to 1. So you're going to use 2 cells, and then you have to do 2, 1. So one of these is definitely an Exum that uses up the 2. The other one, remember 3 hides, we can only hide up to 3 digits, so it's going to be from 1 through 4. So I guess we just put 1 through 4 on here. What about here? I'm trying to see which one to look at next. So I guess this, we don't know if this is Exum or skyscraper, but either way we can put 1, 2, 3, 4 here, because if it's a Exum, it's 1, 2, 3, 4. If it's a skyscraper, it's 1, 2, 3, 4. If it's an Exum, it has to be a 2. So same thing with this 3. Any 3, I guess that's true of. We can just put 1, 2, 3, 4 next to it. Now let's think about 5 then. 5, you have to use 2 cells as well. 3 cells minimum adds to 6. 1 plus 2 plus 3 is 6. So if it's an Exum, this has to be a 2, and then this has to be a 3. So that doesn't affect this penciling at all, but this could be a 2. Now, seeing 5 digits, we can only hide 1 digit. So 2 is the biggest this could be as a skyscraper. So this is only 1 or 2. All right. Either way, this cell cannot be 2. Oh no, this can be 2. If this is 1, this can be 2. Sorry, I missed a case in my head. 5 and 6 go in these 3. 5 and 6 go in these 3. Is there anything I missed here? Okay, actually, interestingly, we know the 3 is going to go 2, 1. So the skyscraper can't be the 1. So neither of these can be 1, actually. Because it would, if it was a 1, it would have to be the skyscraper, and then that would prevent the Exum from being 2, 1. We don't have any other opposing 3s. Let's see. Let's think about this. If this was the skyscraper, it would have to be a 6. That works out very well. If this was the Exum, it would have to be a 1, and then this would be This wouldn't care that much. What am I missing? How do I deduce more about this? I mean, we're not going to deduce these symmetric 3s right now, I don't think. Is it the 5? Okay. Well, if this 5 were a skyscraper, this 3 would be 2, 1. And both the 2 and the 1 would be hidden. Yeah. Look, this would be 2, 1, because this would have to be X sum. If this is skyscraper, this would have... If the 5 is a skyscraper, this would have to be an X sum using 2 and 1, and notice how that completely breaks the skyscraper. It already hides both of these. So that can't happen. This actually has to be the X sum. So it has to be 2, 3. That makes that a 1, makes that a 2, and a 4. That works out. Does add to 6. So we know that this is our X sum, and this is our skyscraper. We can clean this up more. All right. So let's think about this skyscraper then. We are not going to be able to see the 2, 3. It's just not happening. Because there's going to be a 6 somewhere in here. Where can the 6 go? Well, it can't go within the first 2. The 6 could go here. These just have to increase. So 6, one of these 2. Huh. I don't know that I can do more with this skyscraper right now. We could pencil it a bit more. This can go up to 5. That'd be 2, 3. Does that affect this? 2, 1. I mean, so if this was the X sum, it has a huge effect. And sometimes when something has a huge effect, it's worth just in your head thinking ahead a little bit. I don't know if that's the case here, but I'm going to investigate. We'll investigate together. So in my head, I would usually do this, but I'm going to demonstrate. So if this was an X sum, this has to be 2, 1. And you will note that that makes this a 4. Because the 2, 1 then makes this a 4. And so then this would have to be 5, 6. I don't necessarily see an immediate reason that would be a problem. Do we know what these are yet? Not really. Huh. If this was a... Oh, this can't be an X sum anymore. Right, it can't be the 2 anymore, so it can't be the X sum. Okay, so this is the X sum. It's 2, 1. That's a 4. That's exactly what I said would happen. 5 and 6. All right. That's why it worked, because it was right. This is a 3, 6 pair. Okay, so this is a skyscraper. These 2 are already hidden. This can't be the 6. So we can't put the 6 in these 2. That would hide too many. And we can't put a 6 here because of Sudoku. So this has to be the 6. Now, I don't know where the 5 goes. We do know there's a 5 in one of these 2. Do we know what this 3 is doing yet? Oh, okay. We know it's not an X sum because it can't be 2. So, it's a skyscraper. And this 4 is hidden. So this cannot be a 3. Okay. Why is this 4 hidden? Because we cannot put both the 5 and 6 after it. So the 4 is definitely hidden. It's too far away to be seen. And so if this was a 3, the 3 blocks the 1 and the 2. And then we know we don't see the 4. Wait, that just barely works. Oh, no. It doesn't work. Wait. No, it's fine. Sorry, that actually does work. Might be what actually happens. I can mark these. We know this is the X sum, and we know this is the skyscraper. We also know this is a skyscraper. What about this one? This could still... Can this be 2, 1? Is that actually viable? No, because this can't be 1 or 2. So this can't be an X sum. This has to be the skyscraper, which makes this the X sum, which makes this a 1. That's handy. So we know 1's one of these 2. And now we know what all of them are. So this is actually the X... No, this is not the X sum. This is the skyscraper. This can't be the... Oh, this can be the 5. Yeah, it actually works as a 5. Darn. It might be what it is. All right, let's see if there's any Sudoku to do. This box needs 3, 5, 6. Oh yeah, the 6 is placed. I don't know if that helps. 3, 5 pair actually looks down, giving us 4 and 5 here. So this is a pair. It's going to be 3, 4, and this is a pair. It's 1, 2. What can I do here? Oh, 5 in this row, actually, because of this 5, has to go here. So that's 3, and that makes that a 2. So we see the 2, and then we have to see the 5 and the 6. So this goes 5, 6. Yeah, like I said, that probably was what it was. That's 3, 6. That places the 5 here. So now this skyscraper always is going to see this 5 and this 6. We can't hide them. So it can only see this one. So if this was a 1, we would see 1, 2, 5, 6, and that's too many. So this has to be the 3, that's the 4, that's the 1. 3 in the corner, shooting confetti. That's a 3, that's 4 and 3. Over here we get the 1, 2 and 1. We get the 2 and the 4, and we're done. Alrighty. Cool puzzle, Rockrat. Took some thinking. But I got there. Obviously, if you do enough ambiguity puzzles of this exact kind, you get used to the logic and you do it faster. But what's nice about variant Sudokus is often it's the first and only time you'll ever do that specific ambiguity. Or there's a long period of time in between. So you always get to like rediscover that, and that's part of the fun. All right, cool. Well, I enjoyed this. Hope you did too. If you did, then why not leave a like, subscribe, and a kind comment below.